Hello everyone. Our today's topic is breadboard. Breadboard is a very basic element for a electronic spectacle. Okay. Normally, in college, in school or college, in every electronic spectacle, we need to use the breadboard. Right. First, we need to know why we need to use the breadboard. Right. In the electronic spectacles, like the transistor, OPAMP, or any circuit theory practicals, normally we need to use a resistance, voltage source, and the capacitors, inductors, like the right, the elements. So at that time, we need to make some circuits like this, and we need to check the suppose the current and the voltage, right? With the ammeter, we need to measure the current, and the voltmeter, we need to measure the voltage, and we need to see the characteristics of that particular circuit. When we need to do this kind of circuits in the practical, there is two way, right? One is take this element and do the soldering and check the characteristics, right? But the soldering is a permanent process. That means if you have the resistance, suppose if you do this kind of circuit with the soldering iron, then what will happen? You cannot reuse this resistance in the next practical. That means the just like the PCB board. In the PCB board, you can see that all the elements is soldered in that particular board, right? And those elements is not that much reusable, right? What you need to do? You need to desolder that one. That will take time, right? Otherwise, you cannot use that particular items in the next practical or in the next day. So the only solution is the use of breadboard. Okay, breadboard gave us the flexibility to use the elements in the different practicals. Right? So breadboard gave us the flexibility to reuse the particular resistance or capacitor or inductor. Okay, so we need to know that how this breadboard works. Okay, and I told you about the student perspective, right? For the professional, the perspective is they do the circuit in the simulation software, and before they do in the PCB board, what they need to do? They check the circuits by using the breadboard. They do the circuit in the breadboard, take the readings and match the readings with the simulation, right? And they check is it okay or not. Then they take that design and do that one in the printed circuit board for the final assembly. Okay, this is from the professional point of view. So I already told you from the student point of view as well as the professional point of view, right? So now you need to know the breadboard, so internals of the breadboard. In the breadboard, we call this line is the power rail. Okay, this is the power rail. Okay, and these lines are the component lines. Okay, here for this one, all of these holes are connected together up to this line. Okay, and again, all of these points are connected together up to this one. In the breadboard, there is no connection in this particular 2 point. Okay, you need to remember this one. So when you do the circuit at that time, you need to connect a wire from this point to this point, such that these two power rail line would be connected together. But for this connection, you need to use a external wire to connect these 2 points. Okay, so I already told you these lines are called the power rail. Okay, and this is a one line and this is the another line. Okay, there is no connection between this line 1 and line 2. No connection is there. Okay, and in the component line you can see here this is one line, second line, third line. Okay, here this line and this line, there is no connection in the line 1 and line 2. No connection in between to that. But in the line 1, all the holes are connected together. That means all of these holes are connected together like this. Okay, but there is no internal connection between line 1, line 2, line 3, line 4, line 5, dot, dot. Okay, so I think you already understand the internal connection of the breadboard. And now this one will be much more easier if I show you the backside of the breadboard. Here you can see in the bottom, this is the backside of the breadboard. That means in the top view, you can see this one where we need to put the elements like capacitor, transistor, resistor, voltage source. Okay, but backside you can see the connection like this. That's why I told you that this line is the power line 1, power rail line 2. Okay, and here I already told you, you can see here there is some disconnection, right? That means this line and this line is not connected. So you need to use a wire to connect these 2 points. Okay, that means you will just do this short. Okay, now if you give a connection in this point, then you can access this one to the whole power rail. That means from this point to this point, all of this point you can get the connection. Okay, and here you can see in the component line, this is the line 1, 2, 3, 4, and you can see here line 1 and line 2 is not connected together, but in the line 1 all of the points are connected together. That means if I connect a resistance in this point and in this point, that means that two resistances connected together. Okay, now I told you in general where we use the which line. Whenever you get a breadboard, at that time what you need to do, you need to short these two terminals first. Okay, this is the first one. After that, whenever you are doing the any circuit, okay, at that time you will have a voltage source in that particular circuit, right? So what you need to do, you need to connect the V positive, in this particular power rail, the top one. Okay, and V negative in this particular power rail, the bottom one. Okay, suppose you have a one voltage source, but if you have the another voltage source, what you need to do, this is a V1 plus, then you need to connect it in the next one, in the bottom one. Okay, here V minus 1 will be connected in the top one, right? So with the single breadboard, you can use the all of these four power rail, right? Two power rail for the positive voltage source 1, two power rail for the voltage source 2, right? Suppose you have the resistance, okay? You have one resistance, so you need to connect that one. I choose this point, okay? And you draw the resistance and you connect it here, okay? And you have another resistance connected with this one, so you can connect from this one and connect to this point, right? Now voltage source 1 is connected with the resistance R1. Okay, so what you need to do, you need to take a wire from this point and put this wire to this point. That means you connect the voltage source positive point to the resistance R1, as this point and this point are in the same component line, right? And you need to ground that one, so you need to take another wire from this point, as this is the negative terminal of the positive first voltage source, so you can connect like this. Okay, so ultimately the circuit will looks like this one, where is the R1, R2, and this is the voltage source. Okay, so I think you understand this one. So now I will give you a circuit, and please pause this video and try to draw that one in your paper. Okay, and I will do that one also. Suppose they give you this circuit and they told you to do this circuit in this particular breadboard. Okay, so here they provide us 18-volt voltage source. Okay, so what will be our purpose? First, I take a 18-volt voltage source battery, where in this battery I put this one as a negative terminal and put this one as a positive terminal. Okay, suppose this is a voltage source we have. Now we need to connect that one using a wire and put in the breadboard. First, what you need to do? First, whenever you get a breadboard, you need to connect this two terminal such that you can use the full power rail. Okay. Now you already have the voltage source, so connect that voltage source in the power rail. I connect the wire from the positive terminal of the voltage source to the power rail 1, okay, and connect the negative terminal of the voltage source to the power rail 4, okay. That means this whole line is the plus 18 volt voltage source positive terminal, okay, and this whole line is the plus 18 volt voltage source negative terminal, okay. Now you need to connect a 2 kilo ohm resistance, right? And 2 kilo ohm resistance in connect with the positive terminal of the voltage source. So let's connect the resistance first. I connect the one terminal of the resistance in this point and connect the other terminal in this point. Okay. So this is 2 kilo ohm. Now we need to connect a 3 kilo ohm resistance, and 3 kilo ohm resistance is connected with the 2 kilo ohm resistance, right? So you can see here the 2 kilo ohm resistance is end in this particular connector line, right? That means this point, this whole line is the end terminal of the 2 kilo ohm. So we need to connect the next resistance 3 kilo ohm with this 2 kilo ohm resistance with the help of this connector line. Okay, so I connect it in this point, okay, and I connect it to this point. Okay, now you can see here this is the 3 kilo ohm. Okay, 2 kilo ohm and 3 kilo ohm is connected together. Now you can see there is another resistance 5 kilo ohm. That 5 kilo ohm is connected with the 2 kilo ohm and 3 kilo ohm together, right? So that means we need to use this connector line to connect the 5 kilo ohm resistance. So I connect that 5 kilo ohm resistance in this particular point. Okay, and I connect it to the this line. Okay, so this is the 5 kilo ohm. Okay, now you can see here this connected line, all of the points is connected with the 5 kilo ohm, right? And here you can see that the 5 kilo ohm and 3 kilo ohm are connected together. That means the N terminal of the 5 kilo ohm is connected with the N terminal of the 3 kilo ohm. So I need to use a jumper wire to connect these two. So what I need to do, I need to take a wire from this point to connect it to this point. Okay, what I did, I just connect the 3 kilo ohm and the 5 kilo ohm together. Okay, now you can see here we need to connect the voltage source in this particular circuit, right? The 18 volt voltage source need to be connected in the 2 kilo ohm terminal 1. Okay, so I take a wire from this point and connect it to the this one. Okay, connector line. Here you can see that this all the connector line pin are the terminal 1 of the 2 kilo ohm resistance. Okay, that means we already connected the source with the 2 kilo ohm resistance, right? Now we need to connect the negative terminal of the voltage source to the 5 kilo ohm and 3 kilo ohm junction, right? As in all of the points in the power rail 4 are the negative terminal, right? So I can use any point. So I use this one. I use this point and I need to connect it to this point. Okay, so that's all. This is the circuit diagram in the book, and when you need to do in the practical in the breadboard circuit will be looks like this one. Okay, if you do this one, you can easily get the desired characteristics. The common mistake students do is they try to do the practical very fast, and the mistake they do is they just miss, like I just do with the yellow color. What they do, suppose they connect this 3 kilo ohm resistance in this point, okay, and the 2 kilo ohm in this point. So you can see that this connector line and this connector line are not same, right? So there is some disconnection between the 2 kilo ohm and 3 kilo ohm. So after that, you can see that there is some problem in the circuit. You cannot get the output. Okay. So whenever you do the any circuit, make sure the junctions are the perfect or the junctions are the correct. Okay. So this is all about the breadboard. The main thing is I'm in Taiwan now, so I don't have the access of the breadboards. But if I get a good response in this particular video, I will buy all of the electronics component like the breadboard, resistor, capacitor, voltage source. Okay, and I will try to do the practical things and show you in the video. I will do the live and show you the video. Okay, so it depends upon you. If I get a good response, then I will try to do that kind of thing. Thank you. Bye bye. Thanks for your time. Please do share this concept with your friends. And if you like this video, please press the like button. It is really means a lot for me. Bye bye.